Hi kids, it's me again. We're going to do 8.2 today, which is solving square root equations. This is not that hard. I think you'll be able to get the hang of this pretty easily because really where this goes is just talking about inverses. Just like when we did silly things that look like this. When you had 2x minus 1 equals 5, we always did the opposite operations, right? We added 1 to both sides because it was the opposite of a minus 1. And then when you had the 2x is equal to 6, how did we undo multiplication? We divided. So then we divided both sides by 2. So x turned out to be 3. All right, it's kind of the same situation in square roots because what undoes square root? Squares. So you square both sides. And the only thing you have to always remember is to make sure that before you do the operation or the opposite, you have to isolate it. So in order to undo square root, you have to make sure it's by itself. So if you look at exercise 1, it says solve each of the following square root equations which are arranged from less to more complex. All right, and it says to check the equation, so that's easy enough to do. So let's take a look at the first one. I already have the square root isolated, so we're going to square both sides, and you get x is equal to 49. And a quick check, the square root of 49 is 7. All right, so now we have here, it's isolated. We can square both sides. So you get x minus 3 is equal to 25. Add 3 to both sides. And if it's okay with you, I am not going to check them just to save a little bit of time. X is 28. C, square both sides. And you get 2x minus 1 is equal to 16. Add 1 to both sides. 2x is equal to 17. And x is equal to 17 halves. Or you can write it as 8.5. Whatever easiest. So not bad. I did that really fast. So please take a minute and look at them. Look at what I did before we move on to the more complicated ones, D through F. Okay, so in letters D through F, you can see how the radical is not isolated. So we have to use opposite operations to make sure we get that radical isolated. So some people back in the old algebra days used to like to put the lines in here. All right, so the first thing you're going to do is you're going to add and subtract just like before. So we're going to add 4 to both sides. So we have 3 rad x is equal to 24. And then we have that 3 in the front, and we're going to divide that out. So we have rad x is equal to 8. And now, in order to solve for that, we're going to square both sides. So x is equal to 64. E, same thing goes. So the first thing I'm going to do here is subtract 7 from both sides. And I have 2 rad x plus 5 is equal to 6. Divide both sides by 2. These cancel. And I get rad x plus 5 is equal to 3. Now I'm going to square both sides. And I get x plus 5 is equal to 9. And x is equal to 4. How are we feeling about these? Boy, I wish I could hear you. I'm hoping you're saying, these aren't so hard. I can do this. Okay, so again, it's a square root, so that I know I have to isolate that square root. So let's add and subtract first, because that's the first thing we learned how to do. So we add 4 to both sides. So we get 5 rad 3x minus 2. Make sure you're making that radical sign, long enough that it goes over that 2. and now it's equal to 40, and we're going to divide out the 5. Okay, cancel on this side. So I'm left with radical 3x minus 2 is equal to 8. Now I'm going to square both sides. And I get 3x minus 2 is equal to 64. I'm going to add 2 to both sides. And I get 3x is equal to 66. Divide both sides by 3, and x turns out to be 22. If you need a minute to write things down, please do. Make sense of it, please. Don't just copy. Moving on to exercise 2. So which of the following is the solution to 3 rad x over 2 equals 15? Don't flip out because of the fraction. You're going to follow the same rules we just did. We're going to isolate that radical. So the first thing we're going to do is we're going to divide both sides by 3. And we get radical x over 2 is equal to 5. As soon as you get that radical isolated, you're going to square both sides. So you get x over 2 is equal to 25. Now you can either cross multiply, or remember, how do we undo division? Multiplication. So x is equal to 50. Now let's say, for an example, the fraction is totally flipping you out. You don't know what to do. What's another way that we can do this problem? Because we know what the answer is. The answer has to be there. They're not going to give you a multiple choice question where the answer isn't there. So you can actually just write this out, or you could put this into your calculator. You could use your store button, or you could just be putting the different. Actually, you don't even need the equals 15. You can just put this part in, right? With all these x's, try 12.5, 12, try 25, try 40, 50, and see which one is equal to 15. When you finally get right here to 3, 50 will work. Because you get 50 divided by 2, and so looks like a base 3, I'm sorry, a power. So there we go. So you can get 50 divided by 2 is 25, which is the square root of 25 is 5, and I'm sorry, I just did that. Right, 25 and is 5, and 5 times 3 is 15. So it comes out fine that way too. Remember, don't overthink some of these. These multiple choice questions, some of them are hard, but some of them really aren't. Moving on to number 3. Okay, so it says here, a more complicated scenario arises when a square root expression is equal to a linear expression. So in exercise 3, they said consider the system of equations. Again, great question, because it's really combining things that we've done before. So we have y equals x plus rad x plus 3, and y is equal to x plus 1. And A says solve the system graphically using the grid to the right. So the first thing I'm going to do is I'm going to draw my 2 functions. So the second function here, I'll do this one in green, it's simply a linear function. I know the y-intercept is 1. Now you can use your calculator here, and the slope is up 1 over 1. So I know this function's going to look something like this. Oh, that's a really, really, really bad straight line. So let's do it a little bit differently than that. I know it's here. I know it's here. Let's see if I can get a straight line, because it's not so easy sometimes to get my lines straight on this smartboard. I can't use a ruler. Okay, so there we go. So this one happens to be. And I'm going to say this is y is equal to x plus 1. We know we always label. All right, so now let's look at the next one. The next one, I'll get this off of my calculator. And so my numbers are here, here, and here. So this is my y equals rad x plus 3. So already I can see my solution, because in a system of equations, what they're looking for is where the two intersect. So we have the point 1 comma 2, and I put that answer on the graph because that's what they want. So we did A. Done. Not bad at all. Now it says to solve it algebraically. And at the beginning, you might think, well, this is not going to be easy. But when we have y is equal to this, and I have y is equal to this, I can simply set these two equal. So I'm going to have rad x plus 3 is equal to x plus 1. And I'm going to solve for x. Now, in this case, my radical is already isolated. So when I square both sides, I'm going to get something a little messier than we've gotten before, because I'm going to get x plus 3 here alone, but then I'm going to get x plus 1 times x plus 1. Multiply it out, and I get x plus 3 is equal to x squared plus 2x plus 1. Now, we all know how to solve a quadratic. We have to set this puppy equal to 0. I went up a little too far. There we go. So I'm going to bring this x over, and I'm going to bring this 3 over. You do not have to do it in one step, but that's how I'm going to get a 0 on one side. So I'm going to get x squared plus 1x minus 2, and I'm going to put my equals 0 over here now. And now this is a simple factorable quadratic because I have a leading coefficient of 1. So I know it's x and x. Remember, I'm going to read it backwards from here on. So I need two factors of 2 that subtract to give me 1. Remember, there's a 1 hiding here. And the answer, of course, is going to be 2 and 1. I need a positive, so the bigger number gets the positive. Give it a quick check. Positive 2x, remember, loop them. Negative 1x is a positive 1x. So my answers are going to be x equals negative 2 and x equals positive 1. All right, well, that's two variables, but I need that gives me, remember, the system of equations yields a point. So if I look here, I know that one of my points is 1, 2. And how I can get my 2 is I use my other equation. Y equals x plus 1. Well, I know y equals x plus 1, so y is equal to 1 plus 1, which is 2. So this point is 1 comma 2. And this one here, we can do the same thing. Y equals x plus 1, so y is equal to negative 2 plus 1, and y is equal to negative 1. So they're saying that the other one is negative 2 comma negative 1. C says, why does your answer from part A contradict what you found in part B? Well, from part 1, we found only one intersection. We didn't find a second one. The 1 comma 2 is the one that we found. So this is the one that we found. The other one is not a solution. It's called an extraneous root. Okay? Extraneous, funny word. Extraneous means it's a root that we found or a solution that we found, all right? But it doesn't work. So it's very important in square root quadratics that you check your answers, okay? Because if you don't check your answers, you'll find out that you put both of them down and both of them actually don't exist, okay? So let's look at exercise 4 and take a look at the difference when you start checking things. All right, so here we are, exercise 4. Now these get a little bit complicated. It might take me most of the page to do this. So we're going to do the same thing that we just did above. We're solving a square root equation, and these are the type that you're going to be responsible for, not those simple ones at the beginning. So we have, I'm going to move this all the way up, We're finding the solution set of each of the following equations. Be sure to check your work and reject any extraneous roots. All right, so here we go. We already have the radical isolated. So first step, we're going to square both sides. So we get 2x minus 3 is equal to x minus 3 times x minus 3. So let's multiply that out. 2x minus 3 equals x squared. Now, if you want to do it the long way, minus 3x plus 9, you can. But for ease of just writing things down, I'm going to just right away go to minus 6x plus 9. Okay? And the next step I'm going to do is I'm going to move these over because I need this set equal to 0. So I'm going to subtract 2x, add 3. Subtract 2x, add 3. Because what I want is I want a 0 on this side. Now, you can leave the 0 over here, but I think it's kind of odd. But what do you get over on the right-hand side? X squared minus 8x plus 12. Now, like I said, I think it's odd to have it this way. I think it's easier to write it like this. That's the way we're used to seeing it. But it doesn't really matter. Now, this is factorable. So I know that, and it's easily factorable, which is kind of nice. So x and x, factors of 12 that add to give me 8. 6 and 2, that's simple. I know the signs are the same and they're both minus. So I know here I have x minus 6 is equal to 0. So x is equal to 6. Here I have x minus 2 is equal to 0 using our zero product law. And this is x is equal to positive 2. Right? So now to give it a quick check, we're going to check each one. So when we check it, we're going to go back to our original. And our original says square root of 2 times x minus 3 equals x, in this case, x minus 3. So we're going to put in our 6 here and our 6 here. And here we get 12, square root 12 minus 3 is equal to 6 minus 3, which is 3. And the square root of 9 is equal to 3. So this one checks. I'm good here. But now we're going to do the same thing with the x equals 2. So square root of 2 times 2 minus 3 is equal to 2 minus 3. Well, already I can see I have a problem here because this is equal to negative 1. And this is going to equal to 4 minus 3, which is equal to positive 1. So this won't work. So I'm going to reject this because I showed that it does not work. So why don't you pause the video now and try B. All right, just beware because you have to isolate that radical first. Okay, so we're going to have, doesn't matter which way you do it, if you add 2 to both sides, you get 2x plus 2 is equal to the square root or radical x plus 6. And now you square both sides since it is isolated. So we get 2x plus 2 times 2x plus 2, because that's what it means to be squared, is equal to x plus 6. Because when you square the square root, the radical just disappears. Okay? So let's multiply this part out on the left, and we get 4x squared plus 8x, right? Loop it. 4x plus 4x is 8x plus 4 is equal to x plus 6. Now, let's bring this over and bring this over. Again, you do not have to do this in one step. You can absolutely use 2. So we end up with 4x squared plus 7x minus 2 is equal to 0. This is factorable. Not too bad. You can do a little guess and checking here, or you can use the box. and you get 4x minus 1 and x plus 2 is equal to 0. So my answers turn out to be 4x minus 1 equals 0, 4x is equal to positive 1, and x is equal to 1/4. Here I have x plus 2 is equal to 0, and x is equal to negative 2. So I'll wait just a second, give you a little bit of time to write that down. And then we're going to go on and check them. So I'm going to go to the original, which says 2, I'm going to write 2x is equal to rad x plus 6 minus 2. So that's the original, right? So we try the 1/4. 2 times 1/4 is equal to the square root of 1/4 plus 6 minus 2. So I would put this whole thing into your calculator, and this turns out to be 1/2. Turns out to equal, surprisingly enough, a half. This one checks. So I know this is one of my solutions. So don't think automatically that the next one doesn't work. Always make sure you're checking it. All right, so this one turns out to be 2 times negative 2 is equal to the square root of negative 2 plus 6 minus 2. And this turns out to be negative 4 is equal to 0, which of course doesn't work. So we reject that. Okay? So rewind, look at it again, rewrite things down if you need to. But please make sure when you're writing these down that you're making sense of them. Like I said, watching these videos and just taking the notes will do you no good if you're coming in with no knowledge about how to do the classwork. Okay, this one ran a little bit long. I'm sorry, we're at 22 minutes, but I hope you really get something out of it. And until next time, make good choices. I care about you. All right, bye.